question concerns the proper grounding of a metallic weather vane for lightning protection on a garage. A contractor is installing the weather vane and wants guidance on whether using a number 4 bare ground wire to a ground rod would violate the National Electrical Code (NEC). The specific concerns are firstly, the required size of the ground wire according to lightning protection rules, secondly, the minimum distance from other wiring methods, thirdly, whether the ground wire must run outside the building, and fourthly, whether the ground rod must be bonded to the building's grounding electrode system. Yes, a number 4 bare ground wire is permitted for lightning protection. In the 2005 NEC, I cannot find any specific clearance requirements regarding the location of lightning protection conductors. However, NEC 250.10 addresses equipment grounding conductors. Specifically 250.10 states that equipment grounding conductors run with or enclosing other conductors in a raceway, cable, or cord shall be protected by an overcurrent device, unless the overcurrent device protecting the other conductors provides the required protection for the grounding conductor. Since overhead conductors are not typically installed in a raceway, this provision may not directly apply in all situations. Lightning protection conductors are permitted to run either inside or outside a building. The ground rod for lightning protection must be bonded to the building grounding electrode system. NEC 250.54 requires all metallic lightning safety conductors on the exterior of a building to be bonded to the grounding electrode system at the service entrance. The NEC itself does not specify a particular size ground wire for lightning protection systems. However, UL 96A, which is the standard for installation requirements for lightning protection systems, dictates that the lightning protection conductor shall be no smaller than number 6 American wire gauge, AUG, solid or stranded copper, or an equivalent corrosion-resistant conductor. Furthermore, Article 250.54 B requires the electrical and communications grounding systems to be bonded together at the service entrance. In summary, to properly ground the metallic weather vane for lightning protection, firstly, use a number 4 bare ground wire, which is an acceptable size, exceeding the minimum requirement of number 6 AWG copper specified in UL 96A. Secondly, while the NEC does not explicitly state a minimum clearance from other wiring methods for lightning protection conductors, ensure compliance with NEC 250.10. If the grounding conductor is run in a raceway with other conductors. Thirdly, the lightning protection conductor can be run either inside or outside the building. Fourthly, the ground rod used for the lightning protection system must be bonded to the building's grounding electrode system, as mandated by NEC 250.54. This bonding should occur at the service entrance to ensure electrical and communications grounding systems are interconnected, as per NEC 250.54. B. It is essential to consult both the NEC and UL 96 for comprehensive guidance on lightning protection system installation. Always adhere to local codes and regulations, which may have additional requirements beyond the national standards. Proper grounding and bonding are crucial for effective lightning protection, minimizing the risk of damage to the structure and its electrical systems. Remember to consult with a qualified electrical inspector to ensure the installation meets all applicable codes and standards. Additional considerations should include the type of soil the ground rod is being driven into. Highly resistive soil may require additional ground rods to achieve an acceptable ground resistance. Also, the length of the ground rod should be adequate to reach conductive soil, typically a minimum of 8 feet. The location of the ground rod should be chosen to minimize the risk of mechanical damage and to avoid interference with underground utilities. When connecting the ground wire to the ground rod, use a listed connector suitable for direct burial. This will prevent corrosion and ensure a reliable connection. Inspect the connection periodically to ensure it remains tight and free of corrosion. The path of the grounding conductor should be as direct as possible, avoiding sharp bends or loops. This will minimize impedance to lightning currents. If the grounding conductor must pass through metallic enclosures, bond the conductor to the enclosure to prevent potential differences. Ensure all connections are properly tightened and protected from the environment. Use corrosion-resistant hardware and materials whenever possible. If multiple ground rods are used, space them at least twice their length apart to avoid overlapping spheres of influence. Consider using a ground enhancement material to improve the conductivity of the soil around the ground rod. This can be particularly helpful in areas with poor soil conditions. Always follow the manufacturer's instructions for installation and maintenance of all lightning protection components. Keep detailed records of the lightning protection system, including the location of all components and the results of any inspections or tests. Review the lightning protection system periodically to ensure it remains effective and compliant with current codes and standards. In some cases, it may be necessary to install a lightning arrestor at the service entrance to provide additional protection for sensitive electronic equipment. Coordinate the lightning protection system with other building systems such as fire alarm and security systems to ensure compatibility and avoid potential conflicts. Obtain all necessary permits and approvals before starting any lightning protection work. Hire a qualified lightning protection contractor to design and install the system. This will ensure that the system is properly designed and installed according to industry best practices. Regular inspections and maintenance are essential to ensure the lightning protection system remains effective over time. These inspections should be performed by a qualified lightning protection contractor. Keep the area around the ground rods clear of obstructions such as vegetation and debris. This will allow for easy access for inspections and maintenance. Consider using a surge protection device (SPD) at the electrical panel to protect against transient overvoltages caused by lightning strikes. Ensure the SPD is properly rated for the voltage and current requirements of the electrical system. Check the SPD periodically to ensure it is still functioning properly. Replace the SPD if it has reached the end of its service life. The grounding electrode conductor (GEC) should be sized according to NEC Table 250.66, based on the size of the unrounded service conductors. The GEC should be installed in a manner that protects it from physical damage. If the GEC is exposed to physical damage, it should be installed in a raceway or otherwise protected. The grounding electrode system should be tested periodically to ensure it is providing adequate grounding. The test should be performed by a qualified electrician or lightning protection contractor. If the grounding electrode system is not providing adequate grounding, it should be repaired or replaced. Ensure all metal objects on the roof, such as antennas and satellite dishes, are bonded to the lightning protection system. This will prevent them from becoming potential strike points. Consider installing a lightning warning system to provide early warning of approaching thunderstorms. This will allow time to take precautions, such as shutting down sensitive electronic equipment. Educate building occupants about the dangers of lightning and the importance of lightning protection. Post signs near entrances and exits to inform people about the lightning protection system. Develop a lightning safety plan for the building. This plan should include procedures for evacuating the building in the event of a lightning storm. Review the lightning safety plan periodically and update it as needed. The lightning protection system should be inspected after any significant lightning event. This will ensure that the system has not been damaged and is still functioning properly. If the lightning protection system has been damaged, it should be repaired or replaced immediately. Consult with a qualified structural engineer to ensure the building is structurally sound enough to support the lightning protection system. The lightning protection system should be designed to minimize the risk of side flashes. Side flashes occur when lightning jumps from the lightning protection system to nearby objects. Ensure all trees near the building are properly grounded. Trees can be potential strike points and can transfer lightning currents to the building. Consider installing a lightning protection system on any nearby structures, such as sheds or garages. This will help to protect the entire property from lightning damage. The lightning protection system should be designed to be aesthetically pleasing and to blend in with the building's architecture. Use concealed conductors and grounding components whenever possible. Choose materials and finishes that complement the building's exterior. The lightning protection system should be installed in a manner that does not create any safety hazards. Ensure all conductors and grounding components are properly secured and protected from accidental contact. The lightning protection system should be designed to be easily accessible for inspections and maintenance. Provide adequate clearance around all conductors and grounding components. The lightning protection system should be designed to be expandable to accommodate future additions or modifications to the building. Provide spare capacity in the grounding system to allow for future expansion. The lightning protection system should be designed to be environmentally friendly. Use sustainable materials and construction practices whenever possible. Minimize the environmental impact of the lightning protection system. The lightning protection system should be designed to be cost-effective. Choose the most appropriate materials and installation methods to minimize the overall cost of the system. Obtain competitive bids from multiple lightning protection contractors. The lightning protection system should be designed to be reliable and durable. Choose high-quality materials and components that are designed to withstand the harsh conditions of the outdoor environment. Ensure the lightning protection system is properly maintained to extend its service life. It's crucial to understand the concept of the zone of protection provided by a lightning protection system. This zone is the area around a lightning rod or conductor that is considered to be protected from direct lightning strikes. The size and shape of the zone of protection depend on the height of the lightning rod and the angle of protection. The angle of protection is the angle between the vertical line extending from the top of the lightning rod and the line extending from the top of the lightning rod to the edge of the protected area. A typical angle of protection is 45 degrees, but this can vary depending on the specific application. Ensure all parts of the building are within the zone of protection provided by the lightning protection system. If necessary, install additional lightning rods to provide adequate coverage. Consider using a rolling sphere method to determine the zone of protection. The rolling sphere method involves imagining a sphere rolling across the building. Any point on the building that is touched by the sphere is considered to be within the zone of protection. The radius of the sphere is typically 150 feet. Consult with the qualified lightning protection engineer to determine the appropriate zone of protection for your building. They can use specialized software to model the lightning protection system and ensure that all parts of the building are adequately protected. It is important to remember that a lightning protection system does not prevent lightning strikes from occurring. Instead, it provides a safe path for the lightning current to flow to ground, minimizing the risk of damage to the building and its contents. A properly designed and installed lightning protection system can significantly reduce the risk of lightning damage, but it cannot eliminate it completely. Therefore, it is important to take other precautions to protect yourself from lightning, such as seeking shelter indoors during thunderstorms and avoiding contact with metal objects. Educate yourself about lightning safety and take steps to protect yourself and your property. Lightning is a serious hazard, but with proper planning and preparation, you can minimize the risk of lightning damage. The effectiveness of a lightning protection system depends on several factors, including the design of the system, the quality of the materials used, and the skill of the installer. Choose a qualified lightning protection contractor with a proven track record of success. Ask for references and check their credentials. Make sure they are licensed and insured. Get a written estimate from several contractors before making a decision. Compare the estimates carefully and make sure they include all the necessary components and labor. Don't be afraid to ask questions. A good contractor will be happy to answer your questions and explain the details of the lightning protection system. Ensure the contractor follows all applicable codes and standards. The NEC and UL 96 provide detailed requirements for lightning protection systems. Make sure the contractor is familiar with these requirements and complies with them. Inspect the lightning protection system after it is installed. Make sure all components are properly installed and that the system is functioning correctly. Keep a record of the lightning protection system, including the design drawings, the contractor's contact information, and the inspection reports. This record will be helpful if you ever need to make repairs or modifications to the system. Regular maintenance is essential to ensure the lightning protection system remains effective over time. Inspect the system annually and after any significant lightning event. Repair any damage immediately. Keep the area around the ground rods clear of vegetation and debris. This will allow for easy access for inspections and maintenance. By following these guidelines, you can ensure that your lightning protection system provides the best possible protection for your building and its occupants.